All right, let's get started. So here I added one file here on the sign convention. I don't know if we looked at this last time. I'm not able to remember, but maybe we did. So basically, you need to change over here the S, call it a V, but basically this will be the sign convention for the equation that we wrote the other day. You need to replace the S by V. But basically it will be the sign convention. And maybe you remember this equation from structures 1. All those different equation for the bending moments, position of the neutral axis. They have one. This is the equation that we copied the other day over here. That's basically the same as this equation over here, okay? That's what we finished last time. We have here the Q sub naught, where this is the final thickness equivalent. So basically we have this complicated equation to find the shear flow. So next thing I'm going to do is to see what is here this Q sub naught. Okay? And why is this important? All right, so let me go over here. All right, here we go. Okay, I think I just need to move this a little bit down, maybe. Here we go. Okay, so let's say, so you have two choices. You have the choices to have open structures or closed. I mean, really, I should say sections, but it doesn't matter. We can say structures. So basically, open structures or open section is what you should have done in structures 1. So for example, I'm sure you did to find the shear flow into a C bracket structure, no? Okay? You probably did to find the shear flow through an L section. Okay, I'm guessing, no? Okay, maybe you did the one that's a bit more difficult, the one that's like a C section, but where they have different length over here. Okay, this will be open sections. Now, what should be closed section? So obviously closed section will be the simplest one that you can think of, probably will be this one over here. Or we could have something with multiple cells. Something like this. Or you could have something more related to a wing, let's say, that would probably end up solving something like this, okay? So obviously, it's easy to see what is basically the difference between an open section and closed section. Yes?
Can you shut off the lights in the front with the distractor?
Where are the lights? I thought I saw a bunch of them. Is that better?
Yeah.
Maybe I can try to zoom in a little bit more, let me know. But then if I go out of screen, you need to let me know. Okay? All right. So, and I know this is something that I do different than other AE professors, to tell you the truth, that teach this, the shear flows, is that, okay, what should be the shear flow at the end over here? At the ends of the open sections?
Zero.
Should be 0. So basically here, because you have an open section, you have 0, correct? So here could be 0, here could be 0, or let's say here could be 0. Now, so basically what does that mean? What is that important? Because if you have 0 at one point, that means that you can start. So in order to apply this equation here that we copied the other day, let me see, I have it here. Okay, in order to apply this equation, you need to do it from a starting point, no? So you need to know the shear at one point. So in structures 1, what do? You can start either from this point or this point, but then you know 0, you find what is the shear here, and you move around the structure. correct? You can do the same thing over here. Now, what happens when the structure is closed? So what's going to happen? In this case, are you going to have a place where the Q sub naught is 0? It's closed, no? So really, you don't have any location where you know the shear. So where do you start? No idea. So the way I do it is that what do you think will be a way to have 0 somewhere? What could I do? What will you do? What? Okay, what I will do is I will make a cut somewhere, no? And I will say, okay, if I make a cut here, let's say I make a cut here, or cut over here, or cut over here, and I will say that is my starting point. So all of my Q will be 0. But at the end, I will have to find an equivalent Q that will substitute the one that I made the cut, no? Okay, so that's what I will do different if you took this class with Radosta, Islami, or that team. They don't make a cut, they use a redundant shear flow. I'm not going to get into what we do, okay? And then they find what is the value of that redundant shear flow. But basically, it's exactly the same thing that I do, okay? Just presented differently. Okay, so let's say the closed sections. So the open sections contain a location where Q naught equal to 0 and it can be used to start applying the equation for Q of S. However, closed sections or closed structures, okay, open sections, closed sections do not contain a location where Q sub naught equal to 0 and a cut is required to make the shear Q sub S 0 at that location. Okay, so the best thing is to do right away an example, okay? The better way to understand is to do example. Okay, so let's say we have a wind box, or let's say we have this structure that has two different cells, so two different compartments. Okay, we're gonna say, we're gonna add here booms areas. So let's say it will be 1, 2, 3, 4, 5, 6. Okay, so here I'm going to say the room areas. I'm going to call it B sub R. So all of them are 5-inch squares. So where R equal 1, 2, 3, all the way up to 6. Now, so this is B1, B2, B3, B4, B5, B6. Is that okay with that notation? Okay, since they're all the same. Oops, I forgot to do something on the figure. So maybe let me do it now. Okay, let's say the load is going to be applied over here. So we have a vertical load, Vy, which is called a shear load because equal to 10,000 pounds. So obviously here you have panels. Okay, it's not open. You have panels. All right. You know the thickness of every single flange rod, whatever you want to call it, is 0.1 inches. And you know that the length of this between 3 and 4 is 10, 10, and this is 10. So basically it's square. Okay, they give so here. I don't know if we're going to need it or not. I don't think we need it, but. Okay, in case we need it, I don't think we're going to need it, but G equal to 4 10 to the 6 psi. So the question here is to determine the shear flows in the structure. Okay, so I want to try to do this in steps, but and then we'll see what happens with the steps for the future problem. So step 1 on the procedure should be what? This is a cross section, so we need to have to make cuts in order to know where to start, no? Okay, so let's say first thing we're going to do is make a cut. Okay, so for the first time, I'm going to do it for you. So let's say I do here a new little sketch of the so I need to make a cut on each cell so that both of them become open structures, no? Yeah, so like you did in 318. So you have here, this doesn't change. So it would be 1, 2, 3, 4, 5, 6. Okay. So why is this important? Because what do we know now? What should be then Q12? Zero, no? It's open. What should be Q16 or Q61? That should be this one. 0 as well, no? Yeah, so that's why we make the cuts. All right. So now, step 2, maybe I should go to the next page. Step 2, we're going to do the calculate to evaluate the shear flows. So let's see, what do we know about this structure? So section or structure . is symmetric. So what does that mean? That will mean that the IXY, the moment of inertia, will be zero, no? Okay. Now, in something else we have over here is that there is no shear force on the x direction, no? If you look at the figure. So why do I say all this stuff? Is because now, if we go back to this equation here that I gave you earlier, what are you going to have? This term is going to be zero. This is zero. This term will be zero. This term will be zero. This I1 will simplify with this one. Okay, this I. So all this term will be zero. Actually, all this one will be zero. Okay, and you only have this term left, no? Yep. So we'll see. So the previous equation. Let me go to the next page. The shear equation for Q sub S, so Q sub S simplifies as what? So you're gonna have Q sub S equal to minus Vy over Ixx 0 to S Ty ds plus summation I equal to 1 to 6 to the B sub Rs Y sub Rs. Okay? So now what's important is what? This term over here. Okay, so let's see. Let's go back to the initial figure. Okay, so what are the structural elements that we have in this structure? We have panels, no? Yeah. And we have stiffeners, longerons, or whatever you want to call them, no? So basically, this equation, there is two different type of structures that can carry the shear flows. This will be, so what do you think? So one of these ones should be related to the stiffeners, or yeah, to the stiffeners if you want, and one to the panel. So which one do you think is related to the stiffeners? The one related to what? To the B's or to the T? Stiffeners. Okay, is the thickness of what? No, is the thickness of what? This is the thickness of the panel. Yeah? So the T's over here, this is, maybe it's a good question here. Maybe we didn't put, what do we put on the previous equation? We say, if you look at the initial equation, what do we put for T? We say panel thickness, no? Okay, so this is the term that is related to the panels, or panels if you want, and this is a term that will be related to the stiffeners. Okay, so in general, for aerospace structure, it doesn't mean you do it all the time, but we know the panels, if you think about the panels of the wing, we discussed that the first day. What is the main function of the panel on the wing?
Keep the shape.
Keep the shape. Why is the shape important? Because otherwise you cannot generate lift, no? Yeah. So basically you can say, okay, that maybe the panels, the main function is not all the time to carry the loads, no? It's also something important is to transfer the load, something important about the panels, but generally they're not designed to carry the load. Does that make sense? What should be carrying the load should be the wings, or should be the, you want the ribs, the wing span, or the stiffeners and the longerons, no? Okay. So let's over here. We're going to say that assuming that the panels do not carry any of the load. So if you want, this will be the same as saying that T equals 0, no? I mean, we don't have to, okay? We want to make it complicated. But let's say they do not cover any one of the loads. So in that case, what we have, our shear equation simplifies to minus dy over I xx. Summations are equal to 1 to 6 b sub r y of r. Okay, so this equation is not that complicated, no? Okay, but in that equation, what do we have? We have Ixx. What is Ixx? What is I? On the equation, you need to go back to the definition. Go back to the definition. Tell me what is I, xx. Is the area moment of inertia. We discussed that the other day. What is the physical meaning of the moment of inertia? Resistance, and the other one we told last time is the resistance to bending, no? So it's basically, it says how unlikely is something to rotate about a certain axis. And this one would be to rotate about the x-axis, no? Okay, so we need to find that one. So what we need to do is we're going to redo a little figure here very quick. One, two, three, 6. I mean, every time I teach in this building, there's movies on the other classroom. Last semester I was also teaching this course all the way to the end, and there are movies on next door. So anyway, so let's say we have here, so we need a reference frame. Let's say a reference frame. So obviously we know it's about x, but maybe what did I do about this line? It's really x, but what is something that you define in structures? Is it a structure really bending about an axis, or is bending about what? Do you remember the term? What is NA standing for? Neutral axis. So it's always the bending about the neutral axis, no? They call it IXX, but it's the bending about the neutral axis on the x direction, no? That's what, Johnny, before finding the neutral axis, what you need to do, you need to find the CG. And then from the CG, you find the moment of inertia. All that is going to be coming, okay? Now, what is the general definition to IXX? If somebody asks you, what is the mathematical definition of IXX? Is y squared dA, okay? So really, in our case, when you look at this, dA should be equivalent to what? To our base, no? To our boom area. So we could say that this would be basically equivalent, and you know that the integral sign basically is the same thing as doing the summation. Not going to get in details, okay, but integrate is like doing the summation. So we could say that we could do the summation of the y sub r squares times the b sub r's about the neutral axis. So what was the distance between, what was the depth of this structural structure from the figure? It was 10 inches, no? So we can say in this case it's symmetric. This will be 5 and 5. Okay, first example. What would happen, let's say, if the area moment, if the b sub r, so let's say B sub r of 1, 2, and 6 was 5, but the B sub r of 3, 4, 5 was 10. With the neutral axis still be in the middle? No, so you will have first to find the location of the neutral axis, no? Okay, but anyway, we go here. So using that equation, we do the Ixx, saying that it's going to be equal to what? It's going to be equal, so for the first time I do the details, b1 squared plus b2 y squared plus b3 y3 squared plus b4 y4 squared plus b5 y5 squared plus b6 y6 squared. So if you do this calculation, I have the results. That gives you that I sub x is going to be equal to, so basically it should be what? 25 times 5. So 125 and 125 times 6 is 750. So basically we found that Ixx is 750. Okay, so now what does that mean? That we can, all right, so let me redo the figure here since the first time again. So let me redo it here very quick. Okay, we said over here Q12 equal to 0, Q16 equal to 0. Okay, so now what can we do? I can say now, I can say what? Q12 equal to 0. Okay? So I'll start from here, I'll go from 1 to 2, Q12 is equal to 0. Next, Q23 should be equal to what? Whatever you had before, Q12 plus Q sub s, which is equal to what? Minus Vy over Ixx. And what are we doing? We're going from where to where? What is the initial one? We're going to use the first index here. So we get B2 and now what is the equation here should be Y2, no? From this equation, correct? Okay, so basically on this equation, I'm going to put it here if you want. We have Ixx, we just calculated to be equal to 750, and we know Vy was equal to how much? 10,000. Okay, so basically what do we get? We're going to get that Q23 will be equal to 0 minus 10,000 divided by 750. What is B2? What was the value of B2? 5. What will be Y2? What will be Y2? No, what will be Y2? Is 5 because it's the distance from the neutral axis. Okay? So if you do this calculation, we're going to get that, I need to keep doing here, Q23 will be equal to minus 333.3 pound per inch. Okay, so now we did 1, 2, 2, 3. Now we're going to do 3, 4, no? Okay, so we do Q34. Again, the best thing I will recommend you to do, not today, okay, but once you have the assignment, is to create your own MATLAB file to do this calculation because this can be pretty tedious. So now we're going to have 3,4 should be equal to what? Q23 minus dy over Ixs of what? B3 y sub 3. So now we need to be careful because what is Q23? Minus 333.3 minus, so this stays unchanged, 10,000 divided by 750 times 5. But what is y sub 3? -5. So basically it's the same as before, but with a -5. So this is going to mean that Q34 will be equal to what? 0. Yeah? Okay, I'm not asking now, I'm going to ask you at the end if you think that makes sense or not. Now, next one we're gonna go to, so the next one is the difficult one. So we get here now. So we cannot do Q45 because Q45 should be equal to what? Q34 plus Q14, no? Okay. So maybe we need first to say what will be Q14, no? Okay. So before we're gonna say Q14 should be equal to what? So if I want to look at this figure, if you want it to be detailed, hold on, wait 1 second. I will have what? Q12 plus Q16 minus Vy over Ixx. And now what do I need to put over here? B1 was sub 1. Okay, what's the question?
Are you making the same shear flow assumption, like direction assumptions that we were in the previous problems?
No, here because here was making the cut at those steepness and we're gonna run. Okay? We're not making that assumption. This is a different way, okay? Let's do this one. So we have this. So now, what is Q12 and Q16? Okay, if you didn't want, you didn't have to find them. If you don't want, then what are we gonna have for Q12? So it should be equal to negative 10,000 over 750. B1 is 5. What would be Y1? 5. So Q14 is equal to what? Negative 3.3, 333 over 1, 0.3. Now, we're looking at this figure. What, now we can do Q45. So what will be Q45? Yes.
Let's go over your notes.
What will be Q45? If you look at the figure, this is like electrical engineering, no? You think I circuit. So what will be Q45?
Q14 plus 234.
Q14 plus Q34 minus By over Ixx, B of what? B4, Y of 4, no? So we go from the previous results. What was Q34? 0, no? Q14, so we know now that we're going to have Q14 was equal to what? Minus 333.3 minus 10,000 divided by 750 times what? What is before? 5. What is Y4? What is Y4? 85. 5. Okay, so then this will give you what?
Here.
Q for 5 equal to 0. All right. So next, which one can we do? We got 4, 5. Now we can go to 5, 6, no? All right, so we go to Q. 5, 6 will be equal to what? Q for 5 minus Vy over Ixx of B what? B5, Y5. So this is going to give us what? 0 minus again 10,000 divided by 750 times 5. And what is Y5? What is the value of Y5?
-5.
95. So this is going to give you that Q56 will be equal to what? 333 pound per inch. Okay. And finally, which one we will have to do? Q61, no? So what is Q61? Q61 is equal to the Q16, which is equal to 0, no? Okay? All right, now, let's stop for a second, okay? Because this will turn out a lot easier, okay? Just by using logic, but what happens is that with the complicated problems, logic doesn't fall apart, but it's too hard to follow. With the assumption that we made, okay, on the previous lectures, what did we say about what should be the members that will be coming the Vy force? Should be which ones? This one, and this one, no? So if that is the case, what should be the loading? This one, this one, this one, and this one. And what do we find? 0. Okay, so that makes sense, no? With the initial assumptions that we made, okay? All right, so we have this. Okay, so now, step 3, let's see what did I use. Step 3. Okay, because we made the cuts, okay, we changed the structure. So now what we need to do is assume an unknown shear flow in each cell due to torsion producing the same angle of twist on each cell.
You slide the page over.
Yeah, sorry. Maybe I need to move this one more to the right, that way I can. Okay, so basically what happened? Okay, so before we have the cuts, but obviously making the cuts is not to study the real structure. So now what are we doing? Now we're gonna assume some shear flows due to torsion. Q1 and Q2. No, I eat them all, so. But thank you. Anyway, so let's go back to the problem here, to the initial problem. So let's see. If you think about it, okay, what type of load will be encountered by this structure? You will have a shear force, no? Correct? Remember why? But because Vy is not being applied right at the center, this force is going to produce what into these cells? It's going to produce torsion, no? Okay, that torsion needs to be resisted. You think about it, it should be resisted by shear flows that should be going on the opposite direction than the torsion, no? Okay, so that's basically what we're doing. Now, what should be the value of these ones? Well, find out. So here the Q1 and Q2 will be your assumed. I need to move the page?
No.
No.
Which one is Q1?
The one on the left. Okay, and then I'm going to give you the equation for the angle of twist that maybe you might remember or not, but angle of twist equation is okay. Here I call that DC because I don't know if I still have it active or not, but if you look at the sign conventions that we define over here on this figure, what is the coordinate systems that go along the length of the member? Z, no? But maybe you study with dx. I think Radosta uses dx, okay? So be careful with those things. All right, so d theta dz, the angle of twist, so the rest of the equation should not change. You might recall this equation or not, but it's 1 over 2a. And then you do q divided by gt ds going around the cross section. I'm sure you did this in structures 1, no? Use that equation. Okay, so. Okay, so here's where you need to start being careful here. How much time we have? 2 minutes? What time do we finish? 12:30. 12:30, okay. Good. I was like, no way. I have 3 classes in a row, so I lose track of time. Okay, half an hour, that's good. So 4. All right, so now we need to do another figure. You see that I do a lot of figures, no? I always say figures are worth 1,000 words. But not for ChatGPT, huh? ChatGPT, you need to tell him everything, huh? They will make it, I think, once he's going to understand the figures. But not yet. Okay, so we have 1, 2, 3, 4, 5, 6. Where is, yeah, is it this one? Okay, so over here we know Q1. You see apart counterclockwise, this will be Q2. I want to mention something I'm surprised nobody asked me is that why is this shear? Is it different than the other one? This one is due to torsion. The one that we did on the previous chapter was due to just vertical forces, no? Okay. So anyway, so what did we find for Q12 on the previous problem? 0. Okay. What did we find for Q16? What do we have for Q34? What do we have for Q45? 0. Now, what do we have for Q? Let me start by 5, 6. Positive Q56 by 333.3. That will be fine for Q14. We find negative. What do you have here? Yeah, it should be negative. So what did I do here on the figure? Okay. So we have negative. So how do we plot this one? So maybe we can say that I would like to plot the direction. Is that okay? For me, it's easier. So Q14, if it's negative, what does that mean? Is that instead of going from 1 to 4, it's going to what? 4 to 1. So I would like to write here Q14. And then put here just the magnitude. So the magnitude should be what? 333.3, no? Not negative 333.3, correct? I like to plot the stuff on the figures because I always get the equation from the figures. Okay, then what do you get for Q23? Negative, so will be the same thing. We'll be going up Q23, 333.3. Okay, so here, there's two different ways to do this one, but at least the first time we're going to do this one because I think it's a little bit more clear, less confusing. So let's say Q bar over here is the combine of the previous Qs that we found before with these Qs. So this should be equal to what? This should be equal to Q12 plus what? Plus Q1, no? It's going on that direction. Yes.
Could you repeat what Q12 bar is?
Q12, I mean, look at the definition. It's just the combining this one over here plus this one. This one will be going through this one, no? In this direction. Correct? You understand this? Okay. Now, what should be Q bar 23? Is equal to what? Q23 again plus Q bar 1, no? But now, if we look at the figure, what should be Q23? Is equal to what? Is it going on the direction of this one or is it going opposite direction? It's opposite. So it should be minus 333.3 plus Q1, no? Correct? Yeah? Now Q bar 34 should be equal to what? Q34 plus Q1. So it should be equal to what? Q34 is 0, so this should be equal to what? Q1. And all this time I forgot even to do the first one, okay? What is Q12? 0, so Q bar 1, 2 should be equal to what? Q 1 and 1, no? Okay, so this will be, if you look at this, it should be for cell 1, which is this one over here. Now, the one that's a bit conflicting is the one which is on the middle. So what should be Q bar? So let's see, what should be Q bar? We can do 4-1 or 1-4. Let's do 4-1. By looking at the figure, should be equal to what? It's going from the bottom, so it should be equal to what? Q 4-1 or 1-4, is that okay? Because I've already here as 1-4. Okay? Now, what are we going to have? Plus Q1, but now what happened? We have the Q2 on the other side, no? So what are we going to have here? Minus the Q bar 2, no? Yeah? So this one will be equal to what? What is Q14? So Q14 will be equal to the 3.3 plus Q1 minus Q2. Okay, this is the middle. Now, if I do the same thing for Q45, so Q bar 45, that one will be easy now. That should be equal to what? Q45 plus what? Q2, what is Q45? 0, so this should be equal now to Q2. We do Q bar 56 will be equal to Q56 plus Q2. We look at the figure. What is Q56? 333.3 plus Q2. And finally, what would be Q bar 61 or Q16 would be Q16 plus Q2. What is Q16? 0. So the Q bar 16 should be equal to Q Roman 2. Yes.
So why didn't we subtract Q1 on Q bar 23?
On which one?
Q bar 23 or Q bar 32?
3.2. 3.2. What is 3.2? Do you see Q2 going anywhere on 2.3?
I meant Q1. Sorry. Why didn't we subtract Q1 there since it's one opposite direction?
Is that what we did? Well, we put instead of value, we put minus. We said that this one, because we go around, so when we say positive going from 2 to 3 will be positive, and this one will be the negative because it goes on the opposite direction.
So we don't do anything in Q1 there? Or you just
Wait, basically what we are doing here is that what we are assuming, we start from here, we start from 1. So what we're saying, the positive sign for Q is when you go from 1 to 2. When you go from 2 to 3, that should be positive, no?
Correct.
So when you go 2 to 3, is Q1 positive or negative? Yeah, this Q1 here. It goes from 2 to 3, no?
Correct.
So that should be positive. But if you go, and now, is Q to 3 going from 2 to 3 or 3 to 2?
3 to 2.
So that one should be the negative.
Okay.
Okay?
Yeah.
That makes sense?
Yes, sir.
Right. So, I mean, what you see over here is that you see we have everything in function of Q1 and Q2 now, no? Okay? So basically we can say this is what we have over here. But next, what do we say about this assumption? And each cell is producing the same angle of twist. So we're going to say over here, same angle of twist means what? That d theta dz of cell 1 is going to be equal to the d theta dz of the cell 2. Okay? Where we say on the previous page, d theta dz is equal to 1 over 2a. You go around q over gt ds. All right, so what does that mean? D theta dz of the first cell. So let's see if I can get the figure. I'm going to have to back up over here. So if I write down, it should be 1 over 2ay. In this case, the area of the cell 1, 2, 3, 4 will be the same as 1, 4, 5, 6, no? But just in case I'm going to put it this way, so I'll take part of this equation. Now I need to go around. Now, everything out of this one is made of the same material. So I can maybe put here the G. And the thickness okay, of the panel along all the edges is the same. So I can factor out the GT, I can put it outside, no? Okay? So basically now what I need to do is the integral over here around the QDS. Okay, so basically what I'm doing in this case, I'm writing 1 to AGT QDS, no? So, all right, the distance for all of them is going to be the same again. So, what is the distance of each one of the sides? Of the edges? They are all 10, no? Yeah? Okay, so maybe let me put over here. Okay, so here we have then Q bar 1, 2 plus Q bar 2, 3 plus Q bar, I got one set 1, 1, 2, 2, 3, 3, 4 plus Q bar 4, 1, no? Yeah? And all these ones should be multiplied by what? By S, which is 10, no? Okay. So now comes the part that is still, is that what I'm saying? My love for this can be very helpful. So we're going to over here 1 over 2 A1 GT times what? Hopefully I'm able to put everything in one line. What is Q12? Is Q1, no? What is Q23? Minus 3, 3 plus Q1, no? Yeah, this is this one. This is this one over here. What is Q34? No, Q bar 34, sorry. What is Q bar 34? Q1. Now be careful, we need to do Q bar what? For 1, no? What is Q bar for 1? 333 plus Q1 minus Q2 times 10. Okay? So basically from this equation here, we're going to get that. Can you read? Yes. D theta dc of 1 will be equal to 10 divided by 2 a sub 1 gt factor of 1, 2, 3, 4, 4 Q1. Then you see the 3, 3, 3 cancel out. Minus Q2. Okay, so let's call that equation here. Hey. Okay, so now we do the same thing for the other one. I'm going to start speeding up a little bit. I want to finish this part. So next one, we're going to have d theta dz for the second one will be equal to 1 over 2 a sub 2 gt. And this time, what should it be? We go around 1, 4. Let's say we have what? So let's say we have a q. Let's start by the bottom one, q bar 4, 5 plus q bar 5, 6 plus q bar 6, 1 plus Q bar 1/4. So we're gonna have to be careful here with the signs, okay? And this should be times what? Times 10 as before, no? For the distance. Okay. So we get over here 1 over 2 a sub 2 gt. Okay, so this is Q bar for 5 is equal to what? From the previous one, is equal to, what is Q bar for 5? Q2. Now what would be Q bar 5, 6?
33 plus Q2.
Plus 33 plus 3 plus Q2. What is now Q61?
Q2.
Okay, and now Q14, we need to be careful with that one. What would be Q14? What was the equation here?
33, 33.
Okay, but is it going in what direction? Is it going the same as before? Because before we have Q1, Q, this is Q, we had Q for 1, no? So now what do we need to do? Flip the sign. So be careful here. I'm going to put it in red. Flip the sign for this one. So we have minus. So I think it's 333.3 minus Q1 plus Q2. Oops, it should be in blue. Times 10. So once again, you see that now this one is going to cancel this one. So we end up with the equation of 10 over 2 A2 GT factor of 4Q2 minus Q1. Let's say this will be our equation B. Okay, so I remember why are we doing this stuff? Because we said that we're both gonna have the same angle of deformation, no? Okay, so basically we can say this is, so d theta dc of 1 equal d theta dc of 2 means that we have is same as equates A and B, okay? So we have 10 over 2 A2 GT for Q1 minus Q2 equals to 10 to A1 GT for Q2 minus Q1. Okay. I know it's time to go a bit faster, but we know that the size of the cells are identical, no? So we can say that A1 equal A2. In that case, what's going to happen? This term here is going to cancel this term. So that we're going to have 4Q1 minus Q2 equal to 4Q2 minus Q1, which is going to give what? 5Q1 equal 5Q2, which is the same as saying Q1 equal Q2. Okay, again, that's a lot of mathematics that we could have maybe intuitively find out since they are both the same size, no? They should have both the same shear, no? Okay, so we found this one. Okay, so, all right, this is one equation. So, step 4, we need to find one additional equation. And this will be the first step we'll be doing every single time. Step 4, so equate external moments to internal moments. So basically the equation here is summation of moment created by the external forces must be equal to the moment created by the internal forces or internal reactions. So, in other words, what is the figure? All right. The moment created by this force, yes, this external force, should be equal to what? Should be equal to the moment created by all the shear forces inside the structure to resist the external moment, no? Does that make sense or not? Yeah, okay. That's basically what we're doing over here. So basically, we're gonna say over here, I don't know about which one's gonna take the moments. All right, so let's say taking moments, I'm gonna go to the next page. So 1, 2, 3, 4, 5, 6. Taking moments. About 0.4. So I'm going to do a figure. But I'm first going to do this one, summation of the external moments about 0.4 should be equal to the summation of the internal moments about 0.4. And counterclockwise will always be positive for me. So let me do a small figure here. Okay, so we have the Vy over here, which is 10,000. And then we have a bunch of distances. This is 10, 10, 10. I'm not going to do all the figures, but basically we know that this should be 1, 2, 3, 4, 5, 6. This is Q bar 1, 2, Q bar 2, 3, Q bar 3, 4, Q bar 4, 5, Q bar 5, 6, Q bar 6, 1, and let's say this would be Q bar 4, 1. So basically, we already wrote all these ones in function of Q1 and Q2, no? Okay? So now you need to be careful here. So All right, so this is the part of Jenny you do easily mistakes. It's easy to do. So what should be the moment created by the external moment? What is the value of the force? 10,000. What is the value of the arm? About 0.4. What is the arm? 10. Will that create a clockwise or counterclockwise moment? Clockwise, so this would be positive, no? Okay. Now we need to be careful here. So you have to trust the sign. Here now, this should be equal to what? If this is going on this direction, it is opposite direction, this should be equal to what? The value of the force should be equal to what? Q12 times 10 will be what? The value of the force. What will be the arm? What is the distance between 1, 2, and 4? 10 will be the arm, no? The distance. Correct? And if this is positive, we will go on also counterclockwise, no? So we create a positive moment. Now, what will be the moment created by Q bar 23? It should be Q bar 23 times what? The force will be times 10. What will be the arm? 10. Since I'm going to run out of space, I'm going to go to the line. Now, Q41 is going through 0.4, no? So that will not be created moment. Now we go, so Q45 be created moment? No, so we need to go to plus Q bar 56. So if it's going in the direction, what will be the value of the force? Times 10, and the arm will be 10 as well, no? And then we have plus Q bar 61 times 10, again will be 10, equal to 0. So if you do the math of this is going to give you, once you cancel out this 10, once you cancel out this 10, this 10, this 10, this 10, this 10, this one, this one, this one with this one and 1, 0, you're gonna end up with what? With 1,000 equals to 2Q1 after you substitute, plus 2Q2. So basically, you're gonna get the equation here. Q bar 1 plus Q bar 2 will be equal to what? 500. So I'm going to be quick. So next, solving the system, which is very easy. Q1 equals Q2, which is the previous equation, and Q1 plus Q2 equals to 500. This is going to give us what? Q1, Q2 is equal to 250 lb per inch. A few seconds to finish this. I'm going to do it. Okay, so now at the end, we're going to say, if we go back now to these equations, and I'm going to be quick, if we go back to the equation of the Q bars, where were the Q bars equations? If we go back here to the Q bar equations, okay? All right. What would be Q12? What should be this one over here? This should be equal to Q1, no? Which would be what? 500. Now, what should be this one? Q23, we have Q23 to Q bar 23 will be equal to minus 233 plus Q1, no? Yeah, so that will give us what? Okay. So let me do this over here. This will give you, it's 250. No, sorry, not 200, 250. So let me give you this. This one will also be 250. This one will be 250. We know this one will be as well 250. And then Q bar 23 will be equal to what? Will be equal to 83.3. Q56 will be equal to 300 plus the 250 will be 583.3. And the middle one will be equal to what? Will be equal to 333. Okay, so that one stay unchanged, will be equal to 333.3. The only one I have a doubt, this one I have it plotted on my figure positive, but here it's looking negative. So I need to check these ones. I think it should be going, I think this one should be going up by logic, okay? I can double check that makes it going up because logically it should be going up. But when I look at the equation, Q23, yep. Okay, so that's basically what we're going to be doing for the next couple of weeks. So a lot of calculations. Very good.